Hello everybody. Um, right here I have a picture of a pattern of poker chips on the ground, um, and we want to make sense out of patterns in the world. A lot of times they aren't quite this simple, but we see a sort of pattern that at one step it looks like this, and then it increases a little bit, and a little bit more, and a little bit more, and we want to make sense out of those patterns. Um, So this is kind of an exercise in using these numbers to find different patterns. So let's take a look at some of the key um, tools that you can use. So the first tool is to verbally describe the pattern. And so I can look at this picture and I say, well, in this bottom one, I start with 3, and then I get 5, and now I have looks like I added 2 more, so I have 7, and I added 2 more, so I have 9. So it looks like each time I'm adding on 2, right? So this would be a verbal way to describe this pattern that I see. Okay, and then the next step is to make a table of values. So I can say, well, in the first step, and the second step, and the third step, and the fourth step, I have so many chips there, right? So this is the first step. I have 3, and then the second step I had 2 more, so 5, and then I had 2 more, so 7, and 2 more is 9. So each time it looks like I'm adding 2. Right. This is the pattern. Now it'd be really helpful if I could be able to say that for any number down the list. So if I go down and how about 43? What number of chips would there be if I was at the 43rd step, for example? So I could add 2 each time, but it'd be more helpful if I could just be able to take this number 43 and put it into some sort of function, right? Function that I could spit out an output and have my answer. That's really the goal of making sense of patterns, is so that we can use some future event or future number of things and spit out what it is that we want, right? So this is the use of functions right here. So functions can be used here, right? And that's going to be writing symbolically. So it takes a few steps to understand what the pattern's like before we can write it symbolically. So that's the sort of goal that we're looking for. Okay, so I can make a table of values. I see kind of the relationship that's happening is each time I'm adding 2. Let's draw a graph of it. This also helps out. So if I draw a graph, you'd say, well, the first step there's 3, and the second step there's 5. So we call this a bar chart, right? And then there's 7, and then there's 9. You can see that it's just growing like that, right? And each time it's adding 2. Now, there's also what we call a line chart. It's another way you can graph it, right? So the first step there was 3, and then 5, and 7, and 9, right? So, and you can see that how these points actually form call a line, right? So what is that relationship? So it looks like I have a number. I'll take that number and I'm going to add 2 to it. But actually, looks like every time I'm adding 2. So repeatedly adding the same number, plus 2, plus 2, plus 2. Repeatedly adding is multiplication, isn't it? So I say 2 times some number, and then that doesn't quite work though, because 2 times 1 would be 2, and then there's 1 more. So I think it's 2 times a number plus 1. So what happens here? 2 times that number would be 4, plus 1 is 5. 2 times that number would be 6, plus 1 would be 7. So yeah, we call that 2n plus 1. So this now I can give you what my 43rd number would be. It's 2 times 43 plus 1, so 2 times 43 would be 86. And add 1 to it, so 87. See, and now I didn't have to add 2 that many times. I just got right to it. Now that's a helpful way to go about making sense out of patterns. I could look at the other ones, but we're just gonna sort of look at making a table, and we won't get all the way to writing it symbolically, but that'll be in the future. So here we had 1, then 3, then 3 plus 3 more, 6, and then we have the same pattern, right? It's 6 here, so there's 6 here, plus 4 more would be 10, right? So it's sort of making triangles. So it's a verbal way to describe it. And go back to there. Alright, so I can make a table. 1, 2, 3, 4. It was 1, then 3, and 6, and then 10. Right, so it looks like I add 2, and I add 3, and I add 4. So starting to do that helps sort of break things down and helps you think about it. Let's go ahead and graph it. So when it's at 1, it's 1, and when it's at 2, it's 3, and when it's at 3, it's 6, and when it's at 4, it's 10. 5, 6, 7, way up there. Alright, so this definitely isn't the same sort of pattern, right? It's not the same sort of pattern as this where it was a straight line. See, if it was a straight line, it would go through that point and that point. But it's going up faster, isn't it? So it's some sort of curve. And I imagine the next point would be even higher up. So if I add 5 more, right, I'd be at 15. So it'd be shooting up really fast. So that's one way you can look at it, is drawing the graphs, putting it into a table, and then you can start to understand what's happening here. Let's just do the other one, so to be complete. So there's 1, and then 4, and then looks like we have 3 times 3, there's 9. And this one, we have 4 by 4, so that's 16. So let's go back to that. So we have 1, 2, 3, 4, and it was 1, 4, 9, 16. So this one actually, it might be even easier to write this symbolically right out of the gate than this one, even before graphing, because what I'm doing is just taking that number and I'm multiplying it times itself, right? If I look at the graph, it's making squares, right? Squares of that number. So I'll just go ahead and graph it. 1, 1, then at 2 it goes up to 4, and then at 3 it goes up to 9, there's 4, 6, 8, 9, and at 4 it goes to 16, wow, it jumps way up, so 9, and then 5 more, and it looks like it also goes something like that. And symbolically, if this is n, this would be that times itself, or n squared, right? So I already have my function here. My function is n squared. So that's one of the neat things about making sense out of these patterns is if we can get to writing them symbolically, then we have a lot of power in guesstimating, and we can do it with a great deal of accuracy what it is at a certain point. So go ahead and do the exercises that follow.